Now, one of the things that is really critical in balancing reactions is taking that atom inventory. And so in order to do that, you do need to make sure that you understand how to count them properly when we are looking at a chemical formula that is given in the reaction. So this worksheet here gives us that opportunity to practice this a little bit. And we're not going to necessarily do all of these, but I think it's important that you do enough of these so that you feel like you have a good handle on this. So what we're going to do is we're going to take a look first here at number 1. Now, the first step in listing atoms in an atom inventory is to determine what elements we have. And we can determine that based on the capital letters that are present. So in this case, we know we have 2 elements. We have Na and Cl. Now, then we look down here at the bottom to help us determine the number. Now, as we discussed before, when there is no number, that means that we only have 1 present. So for each of these, we have 1 in the atom. Let's take a look at number 2. Now this one is a little bit more complex, but not bad. In this case, if we look at our formula, we have 3 elements here. We have H, we have S, and we have O. Now we look at the subscripts. So next to the H, we have the 2, so that tells us I have 2 atoms of H. Next to the S, I see no number, so we know that means there is 1. And next to the O, we see a 4. That tells us that there are 4 atoms of the oxygen, or the O. Let's do another one. Let's take a look at number 3. Again, I have 3 elements here. I have K, I have N, and I have O. Now next to the K, I have no number, so that is a 1. The N is a 1, and the O is a 3. So those seem actually pretty easy. Now, let's skip down here on your worksheet. Actually, you know what? No, we'll stay there. We'll actually stay up at the top. Take a look at number 11. Some of the challenges come in here when we have these parentheses. If you look here, with those parentheses, we have 2 numbers there. We have some numbers on the inside and we have some numbers on the outside. And how we treat those numbers is actually a little bit different. Let's first list our elements that we have. So we have 3 capital letters, so we have Cu, we have N, and we have O. Now next to the Cu before the parentheses, we see no number. And that Cu is not inside of the parentheses, so it still only has 1 atom. Now the N is inside of the parentheses. There is no number there, so we know we have 1 of them. However, this 2 actually gets multiplied by both subscripts. So in other words, this 2 is telling us I have 2 of everything that is inside. So in this case, I have 2 N's. And then for the O's, I take 3 times 2 to give me 6. Let's do another one of those. Let's look down here at number 15. This time the parentheses are in a slightly different place. We have actually 4 elements here. We have N, we have H, we have P, and we have O. Now, the parentheses are around the N and the H, so that 3 on the outside goes to multiply both of their subscripts. So we have a 3 here and a 12 there. The P has no parentheses, so we only have 1 of those, and the O there we have 4. Now, the stuff that's inside of the parentheses, like this NO3, the NH4, and actually the PO4, these are what we call polyatomic ions. And you actually have a list of those in the blue folder that you're going to be using today to help you. In order to use a polyatomic ion to help with balancing, it needs to be listed exactly as it is. So the N, the O with the 3 needs to be together. There's another one over here. The S, the O, and the 4 need to be together. Okay, you can see the NO3 is here without the parentheses around it. We will get into why the parentheses are there or not there when we talk about writing chemical formulas, but we're not there yet. So what we want to do is just try to help recognize those things because it will help us with some of our balancing. So that's actually how we take the atom inventory, and what we can do now is we can do a little bit more practice with that.